Hello, everyone. This is Alfredo Abate, your current Chicago Oracle Users Group President. Welcome to today's webinar. As an attendee, you'll be in listen-only mode. You can ask questions in the chat window, which we will monitor. All questions will be answered at the end of the presentation. We'll also be streaming live on our YouTube channel, and the recordings will be available there to view shortly after the presentation is finished. It's really great to be here with you today virtually, as the group has not met in person since last August. For those that are new to the Chicago Oracle Users Group, we welcome you. Traditionally, our group meets between 4 to 6 times per year in various locations around the Chicagoland suburbs for presentations, as well as hands-on workshops by Oracle experts, ACEs, and authors. Of course, with the restrictions in place due to COVID, we decided to go virtual to continue to deliver awesome technical content to our members. Today is our 10th webinar in a series of 20 that we'll be holding until November 18th. You can look at our entire schedule on our website and register for all those remaining webinars. And our website is coug.us, and you can also see the link in front of you. For those that are not aware, our user group runs completely unfunded. Our members don't pay any dues, and our meetings have always been free. I'd like to take a moment to thank our sponsor, OAPS Net Partners, for providing the Zoom webinar platform. They are an Oracle Gold partner and systems integrator with specialties in areas of financial business solutions based on Oracle applications both on-premises and in the cloud. They provide services in the areas of AP automation, Apex development, database upgrades, and administration. Next week, don't miss our webinar with Principal Architect from Oracle, Sarah Sumbram, on Fusion Analytics, What is it? You can register for that on our website right now. Today, we are very excited to have Senior Oracle DBA and Oracle ACE Director, Liron Amitzi, present to us on Better Design Than Sorry. Let's design our DB schema. Liron, welcome. I'm going to give you control of the screen.
Hi, Alfredo. Thank you. Okay, so let's start my video as well so you can see me. Okay. And share my screen. Okay. So thank you everyone for joining us, me and Alfredo. And thank you, Alfredo, for having me. I've never been to Chicago, and I think this is the best we can do these days, right? So at least we have Zoom and online webinars. So hello everyone and welcome. My name is Liron, as Alfredo said, and today we're going to talk about designing a schema. This is my contact info. Can you see my cursor as well? Or
yes, we can see your cursor.
Great. Okay, great. So these are my, I'll move that aside for now. These are my contact information. If you want to keep in touch, you can follow me on Twitter. I'm on LinkedIn as well if you want to find me. My website is gotodba.com and my email is liron@gotodba.com. Feel free to contact me, follow me, or whatever you like. Yeah, okay. So if you don't know me, but you can hear on my accent that I'm not a native speaker, this is because I'm originally from Israel, which is the small purplish area here in the middle of the Middle East. And 5 years ago, me and my family, my wife and 2 kids, we moved all the way across the world to Vancouver in BC, Canada, and this is where I live now. And a little bit more about myself. I've been working with Oracle databases since Oracle 7 in 1998. I'm a senior DBA consultant, and I have been one since 2002. I have my own website, gotodba.com. You are welcome to go there, and I have my technical blog there. It's not only what I have on the website. I have all kind of other stuff as well, and you can also follow the blog there and get updates whenever I publish something. I've been part of the Oracle ACE community or ACE program since 2009, and earlier this year, the beginning of the year, I got promoted to Oracle ACE Director. That was a huge honor. And the last thing, I'm very involved in the Oracle user group as well. and I'm currently the president of BCOUG, the British Columbia Oracle User Group here in Vancouver. So let's start. Designing the schema. My goal today with this session is to make you think, okay? I don't know what your knowledge is, and I don't know how much you know about designing a schema, but I want to explain. This session will be divided into two. I want to explain the basics in a very basic level in the first half, and then in the second half, I want us to sort of, however we can over the webinar, to design a schema together. So I'm gonna present you a scenario, and then I want to see what you think. We have a small poll for that, and after that we'll go over a few different designs, and we'll discuss the pros and cons of each design. So the idea here is to just open your mind. Usually people when we talk about designing a schema, usually people come up with a general idea or something that they usually do, and then they say, okay, this is what we should do because this is the scenario and this is how we need to build the tables and so on. But that's not only the case. That's not always the case. Okay, in some cases, different requirements require different designs, and we're going to talk about that. So first, why do we need schema design? What are the goals? So the first thing is to store and retrieve data. Database is there in order to get all the data we need and keep it, and then retrieve it or allow us the ability to get the data when we need. So if some designs, and we're going to talk a little bit about that in later on, but if some designs allow you to pour all the data that you've got very quickly into the database, but then it will be a mess to get it out of the database, we're missing the point. And the other way around, if the data is stored in a perfect way, it's really easy to get it and to understand it and get to the different pieces and exactly what you need. But it's a hell to put it there because you need to process so much process the data so much in order to put it in the database, and sometimes it's just not feasible. Again, we're missing the point. Okay, so the goal is first build a design that it will be easy enough to put the data in, but then retrieve it as well. Okay, so we need to think about both ways of the data flow into the database and out of the database. Next is data integrity. We want the data to be intact, let's say, or to be correct. Okay, if there are some pieces of data that work together, we want them to be, correct. If one contradicts another, that's a problem. Okay, if you're working with databases, the easiest way to explain that is a parent-child relationship between tables. If we have a parent and we have a child, every child has to have a parent, right? So if in some cases we have a child without a parent, that's a data integrity problem, okay? And we're going to talk about some of these as well. Third is performance. We want things to perform well. If we have a query, we want it to return in a reasonable amount of time. If we insert the data or insert a row or update something or do anything with the data in the database, we want it to perform in a reasonable amount of time. And the last thing is flexibility. Okay, sometimes we want to be more flexible or allow more flexibility on the way into the database or out of the database. Sometimes we want to be strict with the way the data is handled in the database. Okay, so all of these are things that we need to consider when we design a schema. What does it include? There are 4 things here. So data types and values, and we'll dive into each and every one of these in the next slides. We've got data types and values, we've got indexes, we've got tables, structure and normalization, and we've got constraints and triggers. So let's start. Design your column and your data. Okay, so I have a small data here, a small table here, 3 rows, and it's called lowest temperature. We have the ID of the row, we have the city name, we have the low temperature date, and we have the low temperature value. Okay, and this is, by the way, correct information. This is a real data. So, for example, in Vancouver in December of 68, the lowest temperature in Fahrenheit was 0 degrees. In Chicago in 85 was the lowest temperature ever, and it was minus 27. Now, there are two things that are we need to pay attention in this slide. The first one is the data types of the columns. As you can see, everything here is varchar, and that might be a problem. Okay, so for example, ID is obviously a number, but in this case, we declared it as a varchar or configured it as a varchar2. And there are all kinds of problems with that. I'm not going to really dive into this issue, but there are lots of information out there about configuring, and the lowest temperature value is the same. There are lots of articles out there, blog posts about configuring numbers as varchar in the database, and these are optimizer problems and all kinds of different different scenarios. So we need to make sure that if we want numbers in the database, we configure the column as a number, right? If we have low temperature F in number here, I will have to enter numbers. But if I have a varchar like I do here, another application that writes data into this table can use other things. It can write 0C in order to say, okay, this is in Celsius and not Fahrenheit. But a different application might not be able to read that because there is no convention, and this is not a number. It really contains text, and it might make a huge problems with some of the applications. The same thing about the date. As you can see, the date here is varchar 11 and not date. So order by might be a problem here, and range predicates might be problems, and the optimizer and everything. So the first thing I wanted to show you is how you configure your columns. The second thing in this slide is this. Obviously, in Tel Aviv, we didn't have minus 9,999 degrees on January 9,999, right? So the concept here is that sometimes people use invalid values to specify something, to say, okay, this is, I don't have the information, or some problems occurred, and instead of having null in these rows or in these columns, we'll just have a common invalid value, and everyone knows about that. But you need to make sure that everyone knows about that. There's sometimes other applications might want to query this table, and they will ask, okay, what's the minimum lowest temperature in Fahrenheit? And it will get like minus 9,999, which doesn't make any sense, right? So all the applications and everyone that accesses this table needs to know that. And it's easier to have something that is generally more understandable. Like, I don't have the information, maybe I'll have null instead of I don't know, a stupid invalid number, okay, or something like that. So these are things that are really important because of performance of the optimizer, because of data integrity. Okay, you need to understand that minus 9999 is actually an invalid number and not a real number, or something like that. Okay, so this is very important when you design the schema and the table and the data types and the columns, to define this very clearly. Okay, the next thing. This is a real story that I had years ago. There was a table called events, let's say. It had ID and then year, month, and day, and all of them, as you can see, are varchar2, which is the problem that I talked about in the previous slide. But here there was a different story. There was a year, month, and day, so I expected that the year will be for January 1st, 2020, it will be year 2020, month January, or 1, or what the convention is, and then day, the day of the month, for example, 1 for January 1st. But this is the data that I saw. So the year was 2020, but the month was 2020-01, and the day was 2020-01-01. So basically, the day column included the month information and the year information, okay? And that was a mess with the optimizer back then. There are ways to solve that on the optimizer level, but still, there is a problem here. First of all, we duplicate the data. You might not care about that, and that's fine. But what happens if a bug in the application shows the year 2020 and then the month is 2019-12? Okay, some, I don't know, problem in the application, a bug managed to insert this data. That's a data integrity issue. Okay, so we need to make sure that there is no data integrity problem here. And again, optimizer problem, and the fact that we are considering we're using dates, but we actually putting them as storing them as a text in the database. Next, indexes. Indexes is the I would say the least important thing when you design a schema, because indexes in general are very important, but they can be changed pretty easily along the way. Okay, so if you define the columns of the tables, and you define other things, the table structure and something like that, some of these are really difficult to change once you implement them. But indexes, dropping indexes, creating new ones, this is something that you usually can do along the way, even after the application is online. And especially with all of the newer features of Oracle, you can do most of them you can do online without any downtime even. So I'll just mention indexes a little bit, but know that this is the least, I wouldn't say important, because it is very important, but it's the least important during the design process. Okay, so when you think about indexes, you need to think about the type of the indexes. We've got B-tree with its pros and cons. We've got bitmap with its pros and cons. We've got composite, and the order is important. If you have 2 or 3 columns in the index, it's really important, the order, so you need to make sure the order is correct. You can have function-based indexes as well. How many indexes? That depends. There's a overhead of each index you create, but it makes the indexes make the queries run faster and allow you all kinds of different things, like less locking with using foreign keys and stuff like that. So you need to decide what the right balance is. And with the autonomous DB of Oracle in the cloud, we're going towards an era where indexes will be created and dropped automatically for us. So this is the beginning of this feature. Okay, so it's quite immature yet. It has lots of restrictions, but I'm sure that down the road we'll have more and more features about automatic indexing, and this would be even less important than ever. The next thing is table normalization. Now, table normalization is a huge topic, and it has all kind of academic papers and stuff on that. So I'm not going to get into that, just to explain the basic concept. So here we have a table with all the data of employees. So we have the employee ID, the name, the department, the city, and the state. Okay, so the problem here is when we have the department names and the city and the states, if we want to change something, or if we want to move something, or if we want to make sure that everything is written in the same way, for example, IT versus information technology, or HR versus human resources, and we need to make sure that everything is written in the same way, usually what we do is just split it into a lookup table. Okay. So we have a departments table, and now we split it into two entities, two tables, the employees and the departments. The departments table holds each department only once, and the department ID is in the employee table. And here, once we have the department entity, we can add more information like the department manager and the address or whatever. Okay, it doesn't make any sense to put all this information into the employee table. And another thing that we can do is split the cities. Now we can split the cities and the states into different tables, like cities and states, or we can have the city and the city will contain the state information. It depends, what your requirements are and how you want to handle this data. But this is generally how we normalize. And these small tables usually are called lookup tables. Just an example why this is important. In 1992, and that's a true story, a city or town in California called Grover City, they wanted to change the name into Grover Beach. So they did that. And now if we have employees and we have the city the employee lives in or work in or whatever, we need to update the name of the city, right? Because the city changed its name. So in number one, we update the employee table because everything that's before the normalization process, the name of the city was in the employee table, and we updated employee and we changed the city from Grover City to Grover Beach, where the state is California. And this will update all the employee table, and this might take a long time, require maybe downtime or whatever. On the opposite side, if we split the table, if we normalize the schema and we split the table into employees and cities, the city ID doesn't change. We just need to change the name of the city from Grover City to Grover Beach in the cities table. Okay, so that's very easy. Okay, we can also get a list of cities in a much easier way, just using the cities table. So this is the concept of normalization. Next topic is constraints and triggers. And this is quite straightforward. We should use constraints in order to enforce data types and values. For example, if we only want a value of true or false, we can have a constraint that will not allow any other value. And if we do that in the database is the only single point we can really enforce that, because we might have different application accessing the same tables. So we should do this in the database to enforce the consistency across all applications. So we can enforce data types, we can enforce values, we can enforce parent-child relationships with foreign keys, we can enforce uniqueness of values and not null, and so on. And we can use triggers for a more complex scenarios. If we have scenarios when we need to perform a more complex logic to validate that the data that was entered is correct or valid, we can use triggers for that. Okay, it has overhead, that's true, but you need to choose the balance between data that might be incorrect and performance or overhead on the database. So that's something to consider, but that's definitely something that we should do. And just as a sort of a summary, not really a summary, but sort of a simplified example about how different requirements behave differently. Okay, so we have OLTP, the classic, the lot of exceptions, but the classic OLTP application versus the classic data warehouse application, a very simplified example. So if we are talking about saving space in OLTP, we would like to avoid duplicates. In data warehouse, we don't care about duplicates, but we will usually compress them. Data integrity in OLTP is very important. In data warehouse is less important because usually data warehouse takes the data from OLTP systems. So if the data is correct in the OLTP systems, it will be correct in the data warehouse system as well. Or we can just, verify that during the insert, but it's data that we usually don't change, right? It's static data. So once it's there and it's correct, there's no problem. We don't need to validate it all the time, as opposed to OLTP that the data changes all the time from sometimes multiple applications. So we need to make sure that everything is valid. Normalization in OLTP, we will usually normalize. In data warehouse, we will denormalize in order to allow more complex reporting in reasonable performance. Contention. OLTP will want to avoid contention. There will be lots of people working on the same data, on the same data objects, and we would like to avoid contention in data warehouse. It's pretty much irrelevant because there are very few processes that load the data and then everyone else just queries. And performance in OLTP, when we click the button, we would like to see instant response. In data warehouse, these are usually reports. So if the report takes, I don't know, 10 minutes, half an hour, maybe even overnight, maybe it's okay. So in these two cases, in OLTP and data warehouse, the classic ones, we will design the schema in a different way. Okay, so there's no common design rules. It just depends on your specific requirements. Okay, so this was the general overview about schema design. And now what I want to do is to design a schema with you as much as possible over the webinar. So this is a scenario that I'll provide, and we'll discuss that in the rest of the session. So we would like to write a software for books and more. Okay, this is a bookstore, and in the bookstore, or I don't know, yeah, let's call it a bookstore. And in the bookstore, they have 3 different types of products. We've got books, we've got magazines, and we've got audio CDs. And these are the attributes or properties that we have for each one of the products. So the ones that are underlined, as you can see, are common. Okay, each and every product has a title, has a date, let's call it release date, and the price. But each one of the products has 2 attributes or properties that are unique for that product. So books have author and number of pages, magazines have publications and frequency, and audio CDs have a musician and number of tracks. Okay, so how would you model this information? How many tables will you need? Now, don't use any lookup tables. Okay, if we talk about authors and you want a table for author's name, don't count this. Okay, I'm interested in the basic, very generalized, basic, simplified model. So for these properties of each product, 3 products for this type of software, how many tables would you need? So think about that for a minute. And Alfredo, we created a poll to get input from you. So Alfredo, if you can start the poll. Thank you. Okay, so sorry?
You should see it, right?
Yeah, I see it.
Okay.
I hope other people see it as well. So for these specific scenarios, this specific software, how many tables would you need? And you have 1, 2, 3, 4, 5, or more than 5 in the poll. So quickly choose the answer you would choose to, build this, again, without any lookups. And then let's see what you think, and then we'll go over different scenarios or different design options, and we'll discuss each other. Okay, how much time do we have to do this poll, Alfredo?
We have as much as we need. We can end whenever you're ready.
Okay, so let's give another, I don't know, a few seconds.
Are you able to see the results?
No, I just see the poll, like a regular attendee. Okay, I guess that's enough. So you can close the poll, and I guess you will be able to show the result, and then all of us can see that. Okay. Yeah. Awesome. Oh, that's interesting. Okay, so most of you said 4, which is very interesting. Some said 1, 2, and 3. None said 5 or more. That's really interesting. This is the second time that I present this session. And in the previous time, in the previous presentation, I got people saying 5 and more, which is really interesting because I don't have a solution for 5 and more, but I definitely do have 1, 2, 3, and 4. So that's really interesting. Okay, thank you very much, guys. And let's start talking about each option. Okay, so the first design we're going to talk about is the single table. I call it a one big happy table. And just to explain the color code and the thing at the bottom here. So when I presented a solution, columns that are in white background are the common ones. Okay, so in here, I've got ID, I've got type, and then the three common properties, the title, date, and price. Okay, now the red ones are for books, and I know a few people who are colorblind. So because I use the color codes here, for those of you who may be not able really to distinguish between the colors, I also wrote in parentheses B, M, and A. Okay, so the red or B in parentheses is the 2 unique columns for books. The blue or the M in parentheses is magazines, and A in parentheses or yellow is for audiobooks. Okay, audio CDs, sorry. Okay, so one big happy table. We have all the columns here. Okay, so we have the ID of the object or the specific product, and then we've got the type, which is books, magazines, or audio. We've got the title, date, price. This is common for everything. And now, if I have a book, the author will be full, and the number of pages will be full, but the publication and the frequency and the musician and number of texts will be null, and that's perfectly valid, right? So this is the design for one single table. Pros and cons, it's very simple. It has very good performance. Okay, everything is in one table. Once I get to the row, I don't have to join anything else. I just have everything I need. Okay, so in general, it will be good performance. However, it has a bad contention issue because we have one table and everyone accesses the same table, right? So this might be a problem when we have lots of access to this table. Also, if I need to change something or I have a problem with this table, everything goes down. If I want to only, I don't know, disable access to books, I can't do that, right? I can do everything in the application side, but not on the database side. In the database side, everything is in the same table. If I need to do something to this table, it means full downtime for all the products. And unnecessary scan of irrelevant data. So if I need to access something and I don't have indexes or something more smart to use, and I just need to scan the entire table, but I'm looking only for books, in this case, I will scan the entire table, not only the books table, but I'll go through or I'll go over the rows relevant for audio and magazines as well, not only books. Okay, so when I scan the entire table, even if I know the type of the product, I can't choose scan only this type. I'll just scan the entire table, and that's unnecessary. Let's go for the next option. 3 tables. This is that makes sense as well. You say, okay, we've got 3 different products, so that let's split that into 3 different tables, right? So we've got the books, magazines, and audio. Each one of the table has all the 5 common properties: the ID, the type. In this case, I'm not sure we even need the type because the table means the type. And then we've got the title, date, and price. And each table has the unique columns for this specific product. Okay, so books have author and number of pages, audio have musicians, number of tracks, and so on. This is simple as well. Again, pretty good performance. It allows us access only relevant products. So if I need to do something crazy, but only on books, like, I don't know, count all the books, for example, I can just go to the books table. I don't touch audio CDs. I don't touch the magazines rows. I just access the books and I do whatever I need on this table. Okay, changing the structure of one product. For example, I want to do something on the audio table and I want to, change something completely there. So that blocks me to access this table, but books and magazines are, intact. You can still work on them easy. And less null columns. In the first scenario, we had by definition, we had 4 columns that are null, right? For books, we had the audio and the magazines columns null by definition. Here, we don't have that. The benefit of that is that this is obviously a very simplified example. So in more complex scenarios, more complex applications, if you use the one big happy table, you will have a very large table with many, many, many columns. And at some point, this might cause a performance issue or maintenance or management issues as well. So I would be careful about that in the very wide tables, but in small tables, you definitely can do that in one table. But in this case, we don't have this problem, right? We take that each product has its own table, and that's it. No null columns. Difficulty, adding another product. Okay, so if we have another product, we will need to create another table, and then we'll need to change the application to access this table. So the flexibility here is not great. In the first scenario, if we have another product, we will need to add more columns and maybe add something to the application to query these columns, but the table is still the same table. The common columns are the same common columns, so most of the things won't be different. Here, we will need to change basically everything, okay? Or much more. So the flexibility here is not that great. When I want to query all products, for example, how many products in general I have in the table, in the store, I will have to count star 3 tables and then combine the results, right? So this is also an issue. And if I have an item that I don't know the type, for example, I have the title, but I don't know if it's a book, a magazine, or an audio CD. In this case, I will have to look in all 3 tables. In the first scenario, or the first design, I will have to query only 1 table. And this is make the previous point, or the adding another product point, maybe even more critical, because if I have a code that searches a specific title, which I don't know the type of the product, when I add another product, I need to remember to add the new table into this logic, because now I will need to access 4 tables in order to find the product that I'm looking for. Okay, so these are the pros and cons of this specific design. Let's move on to 4 table, which was the popular answer here. And I know I skipped 2. 2 will come right after that. Okay, so we've seen 1 and we've seen 3. And now let's see the 4 table solution. So in this case, we have 4 tables. One is the items table. This is a general table with only the common properties. And then we have only the additional columns in different tables. So all the common columns will be in items, but then the book-specific properties will be in the books table with ID that refers to the items table, and audio will have the audio columns with ID that refers to the item table, and magazine is the same. Okay, so we have one general table, and then we have one table to additional table to each of the products or product types. Pros and cons. This is a classical and straightforward RDBMS design. Okay, this is the way we usually normalize our data. Okay, the one table model was the denormalized model, and this is the normalized standard model. So it's very common, it's very understandable. Okay, it's really simple to use the common properties. For example, I said I want to know in the three table model, I said that that's a problem when I want to count how many products I have in general in the store. I needed to count each table separately and then add the result. Here, I have everything I need in the common table, in the items table. I just count that, and that's it. If I want to search for an item that I don't know which type it is, it's really easy as well. I have the title or the common properties in the common table. I just need to scan this table, and that's it. Queries require more join. Now, this is an RDBMS. We're working with Oracle, which is a relational database. We expect to see joins in the queries, and that's perfectly fine. Joins are great. Okay, I put that as a con in this scenario, because as the model gets more and more complex, when you join more and more table, that's you will start seeing performance issues, okay, or complexity issues with your queries. So I put that here, even though we like this model. Most of you chose this model, and that's great. This is, again, the classical RDBMS design. And we would like to, it's perfectly fine to have joins, but if you normalize more and more the model and you make it more and more complex with more and more tables, eventually you get queries with, I don't know, 20 tables join. And this is where problems, you see problems. Okay, you might have all kinds of different issues with writing the queries and debugging them if you have any problem, or performance issues and stuff like that. So that's why I put it there. Again, join of a few tables is perfectly fine. Even more complex join is perfectly fine, but you need to think about that as well. And adding another product, this is better than the three table model, I think. Adding another product, first of all, you have the common table, so that's, you've got that's there, but you will need to add another table into some of the logic of the application. And again, it has some flexibility, but it's not great. Okay, so let's move on to the two table. Okay, two table model. So here we have a completely different concept. We have the items table like before, like in the 4 tables model. And then we've got a properties table. And the properties table is ID, property name, and property value. And as you can see here in the example, we've got ID 1, that's a book. I didn't show that, but that's a book. And then we can see the author is Stephen King, and num pages is 7,000. If you read Stephen King, why I put 7,000 here. He writes long books. So these two properties are two different rows, but they basically relate to the same book. Book number 1, book with ID 1. It's the same entity. Okay. Number 2 is an audio CD, and the musician is Pink, and so on. So basically, for each property, we have ID of the item, and then the property name, and then the property value. Okay. In some cases, people will say, oh, but this is text and this is number, and some of these might be dates. So we can split that and have the property value string, property value number, property value date. You can do that as well. I've seen that. it makes things more complex, okay? But it allows you to control the data type. Okay, so this is the concept of the two table. This is completely different than what we've seen till now, and it has completely different pros and cons. The huge pro is that it allows amazing flexibility. You want to add another product, no problem at all. You just add the data. You don't need to change anything in the database. Even the application can be very flexible with that. Okay, so we don't really need to change basically anything or hardly anything in order to add another product or change even the schema design. Okay, not the hard schema design in the database, but the logical design in the application. The entire structure can be just changed on the fly. You want to add another columns, you want to remove something, you want to change something completely, very easy, okay? But it comes with a price. Enforcing constraints is practically impossible, okay? If I want to make sure that, I don't know, parent-child, in this case, there's not many options for parent-child, but if we had parent-child between different tables, not only the items and the properties, it's practically impossible to do, okay? It's more complex with different data types. As I said, you can increase the table, but it makes it even more complex. And have you tried querying this thing? So before I go into the queries, I'll just, you know what, I'll say that at the end. So queries. Query number one is very simple. I would like to get all the books of a specific author. So it would be select star from items where type is book and the ID of the book or the item, I'm not sure it's book, but basically it's the item in the item table. The ID is the ID from the props table where author, the property name is author, the property value is Stephen King. This will return, I'm going back, this will return all these rows, right? And where author is Stephen King, I will get all the ID of the books. So I take all the ID of the books and I then query them from the items. Okay, so that's fine. Now we're getting a little bit crazier. Okay, how much? Okay, we have 10 more minutes. So yeah, I think we're good. So querying number two is a bit crazier. We have a specific author or number of pages. For example, I would like to get all the books written by Stephen King or the books that have 7,000 pages. So I need to get all the rows that property name and property value, this pair is either author Stephen King or number pages 7,000. I take all the IDs and then I go to the items table and query the rows. That's a bit crazier, but okay, it's not too bad. But now I would like to get all the books that are authored by Stephen King and have 7,000 pages. And this is much more difficult because, as you remember, I'm going back again. As you remember, these are two different rows. I cannot have and between them. I cannot have property name is author and property value is Stephen King and property name is number of pages and property value is 7,000, because these are two different rows and of all of these will return nothing, right? So what I do is this. I query all the rows that are author Stephen King or number of pages 7,000. I get all the IDs where the count is 2, meaning I have both rows with the same ID, and then I take this ID and go to the items. Okay, and this is only for a simple query that have something and something. If I need a more complex query with X and Y or Z, that will be, oh, sorry. something popped up here. Okay, that will be very, very difficult to create. Okay, so these are the cons of the two-table model. Okay, with the properties table. Another option is a single table, but a bit different. I'll have all items, and then I'll have the common properties, and all the other info, the specific info for specific product, will be in a JSON or XML or whatever. And here you can see the example: ID, type, title, date, price, and then other info will be a JSON that contains author Stephen King, num pages is 7,000. Okay, and let's go over this. This is very easy for developers to handle and extremely flexible, but it's not really a relational database system. Okay, so I would use that if you have some other information that is not really part of the model, or some extension of the model, or something that is really difficult to do in any other model. But I don't like using that as a general rule, okay, or as the basic model, because it's not really relational database management system. You cannot enforce anything by definition. JSON is schemaless. So you cannot enforce foreign keys, you cannot enforce data types, you cannot enforce values, you cannot enforce anything. So that misses the point of having a relational database system with all of the benefits it provides. Okay. And just as an example, specific author and specific number of pages. There you go. The other info with Oracle, with the JSON extensions these days, you can just go and write other info dot author is Stephen King and number of pages 7,000. Really straightforward query. It works well. You can index that, I think, and there's no problem at all. Okay, so which one is the best? And that's the question that we get all the time. Which one should I choose when I have a question, a problem or a scenario? And the answer, like always, is it depends. And it depends on many things, all the things we talked today. So performance, some will perform better, some will perform worse, but will have other benefits. So you need to define what your requirements are, and based on that, decide which design is the better fit. Okay, flexibility, and I'll tell you a story about that in a second. Data integrity, can I allow constraints? Do I need to have constraints or data integrity checks and stuff like that? Or I don't need that, and then I can go to schema models that don't allow data integrity checks, but I don't care about that. Querying, how complex is the query? Will you need to use lots of different crazy queries or just simple ones? And that also depends on the model will also help you understand if you can query easily or not. And space consumed in the database as well. So these are the concepts, and just one small story, and that would be, I think, the end of the session. So, story about flexibility. Quite a few years ago, I had a scenario with one of my clients about adding some data into their model, and we checked all the options, splitting that into a different table or add that as more columns that might be null and stuff like that. Basically, I was debating between the concept of the one table and the four table, let's say. Okay, splitting the extra data into a different table, or the two tables with the more flexibility, the properties value table, or just keep it in the same table as columns that might be null. And my colleague in my company, he worked with a different client, and they have exactly the same problem or a very similar problem, and he was debating about the same question, which model to choose. And it's funny, the decision at the end was completely opposite. So for my client, I chose the one table. We just added columns at the end of the table that might be empty, might be not. And the names were like, additional value 1, additional value 2, or something like that. And the reason is that they had a very quite complex model. And the problem is that they ran on a very not powerful appliance. Okay, so the server that they have, or basically they sold appliances to customers. So their appliances that they sold to the customer, and they had the database in them, they were very, very not powerful computers. Okay, so I didn't want to overload anything. I didn't want to go to a different table and join and scan indexes. I just wanted to have the data there. So we decided to put the overhead on the application to figure out which one is value 1, value 2, and so on, and have them null sometimes, as opposed to make a more complex scenario. And my colleague, and he worked with, I told you, with a completely different client, but they decided that the most important thing for them is to be flexible, and they wanted to change the structure on the fly without changing anything in the database. So they went for the two-table scenario, two-table model. So they had the table, the main table, and the properties table in their application. So they chose a completely different model. And this is because their needs were completely different than my needs or my client's needs. Okay, so there is no real answer. There's no one golden rule how to design your schema. But I hope that by giving you all the different options and the pros and cons, now when you have some problem or something to design, or application to design, you can take all of this into account and choose the right one. So if we have time, and I don't think we do, but it will be in the presentation. That's an object-oriented design, which is crazy on a different level, and that's pros and cons, but I don't want to get into that, so I won't exceed my time. And that's it. So I hope you enjoyed, and if you have questions, I'm here for another couple of minutes, I guess. And again, these are my contact information, so if you would like to reach out, feel free. And thank you, Alfredo, again, for having me.
Thank you so much, Liron. This was a great, excellent presentation. Like
Do
I
you
said,
have any questions?
I don't see any questions at the moment. We'll give folks, maybe 30 seconds or so.
Yeah.
And yeah, like I said, we really appreciate you presenting for us today. Hopefully one day we'll have you in Chicago in person. That would be awesome.
Yeah, I hope so.
Yeah, I hope so too. And then, yeah, Liron's website, which is a very good blog, go2dba.com. And, he's got the last couple blog posts that I've been following is on Oracle Standard Edition high availability. So if you don't know what's new with all with how that works and the features, very good posts that he's been putting together as a series. I would highly recommend reading that. And that's it. Next week, we have Sarah Sumbrum is back on, what is her title again? It is Fusion Analytics. What is it? So be looking forward to her next week, but it'll be same bat time, same bat channel again next week. All right. Thank you, everyone.
Thank you.
Okay. Have a good one. Bye.